Hello, this is a video to help you complete the pendulum experiment, or rather complete the data analysis for the pendulum investigations. So let's have a look at the data sheet. You've got your name and the date. And here in this section we're looking at the measuring instruments. We use the tape measure, vernier calipers, weighing scales and a stopwatch timer. Let's have a look at the characteristics of our measuring instruments. The range, this is the maximum measurement that can be made with the instrument. So let's take a look at our tape measure. This is the tape measure that I used. Let me just focus. Oh, okay, it's focusing. All right, almost there. There we go. This is the tape measure I used, but you may have used a smaller one. And this is 25 feet. So we could come over here now and we can put 25 feet. So our range for the tape measure is 25 feet. Now 1 foot is about 1/3 of a meter. So we could divide this by 3. So that's roughly 8 meters. And now the next thing is the precision of the tape measure. So if we look at our tape measure and we open it up, the precision is going to be the smallest increment. I'm just trying to get that so it can be seen. Here we go. Okay, that's the best I can do. So if we look at the smallest increments that we use the centimeter scale. And we can see that the smallest divisions are this minor scale here, and that is a millimeter. Okay, so it almost says it here, metric, millimeters and centimeters. So the precision is the smallest engravings on our measuring device there, which is 1 millimeter. So let's put 1 millimeter here. The vernier calipers, I don't have the, oh, I do have something similar. Let's have a look. So let's have a look at the vernier calipers and try and do the same kind of analysis. So these are my calipers here, and let's find the range. The range is the largest thing we can measure. So I can slide this jaw all the way up to around, you can see 15 centimeters. Okay, so this is, we could put that in millimeters, and the precision is the smallest division that we can measure. On a vernier scale, the smallest that we can measure is going to be a fraction of a millimeter, and this can measure to the precision shown here, 0.02. Okay, the plastic ones that you'll be using can measure to 0.05 precision. So let's put that in. So the vernier calipers can measure up to a maximum of 150 millimeters. With a precision, in my case, of 0.02 millimeters. Now the weighing scales. Let's take a look at the weighing scales that we used. So if we take a look at the weighing scales, I'm just going to show you the, well, that's upside down, so let me try and do that properly. Here we can see the range, so it can measure up to a maximum of 5,000 grams. And then the times, this goes with the precision. It's the smallest mass change it can measure, which is 1 gram. And if we were to turn this on, okay, let me see. Takes a while to turn it on. Ah, there we go. Okay, so it's measuring to the nearest gram, not to the 0.1 of a gram. Let me just catch the light a little bit there, but to the nearest gram. So let's go back to our data sheet. We know the range is 5,000 grams, so always putting the unit there, and the precision is 1 gram. The next thing is a stopwatch timer. I used my phone, and let's take a look at the phone. Okay, so this is my phone right here, and I've got it on the stopwatch mode, and when I press start, you'll see that this moves very rapidly. So what we can kind of see what this is. We can understand just by letting it run for a little bit that this is a number of seconds and this is a fraction of a second. So we can measure to the 100th of a second, and when these seconds here get to 60, then the minutes will increment. Now I think we can pretty much let this timer run until the battery of the phone runs out, and at which time, if you get more than 60 minutes, it will then switch to hours. So this can measure for quite a long time. So I think right now, just as a screen as it is, it can measure at least 100 seconds. Okay, just 1/100th under 100, not 100 seconds, sorry, 100 minutes. So I'm just going to put over here, oh, moving back, sorry about that. Oh, did I close it? No, there it is. I think, yeah, this would be good enough. 100 minutes, sorry about that. And if you want, you could even do something like this. This means you can measure upwards of 100, at least 100 minutes, with a precision of 0.01 of a second. Okay, that's the smallest time increment it can manage. So let's have a look here. We would have measured the mass of our pendulum bob, and this one we should have measured it. Hopefully when we weighed out the clay, we got close to 10 grams. And when we weighed out this one, we got close to 20 grams. We should have measured the diameter with our vernier calipers. And I think this one, what I got was about 25 millimeters. And for this one, I got about 20 millimeters. Okay, you can put your actual numbers in there. So, okay, so what we've got now, we've got the periods for 10 oscillations, length equals 20 centimeters. And for small angles, and we've got 3 experiments. So the first time I did the experiment, I got 9.14 of a second. When I did it again, I got 9. And when I did it again, I got 9.07. This is with a 10 gram. Let's move on. For the 40 centimeters, I got 12.82, 12.8, 0, and 12.77. Now for the 60 centimeters, I got 15.57, 15.65, and 15.67. Okay, so let's now enter in our results for the 20 gram sphere, and for that one I got 9.15 first time round, and then I got 9.04, and then I got 9.17. For the 40 centimeter length pendulum with 20 grams, I got 12.88, 12.86, and 12.70. And then for 60 centimeters, I got 15.57, 15.75, and 15.70. Yeah, please enter your own results for that. So here we've completed our data entry on the first sheet. Of course, put your name and date there.